we are going to be doing graph interpretations for functions greater of together. Now, this is a very good question. Now, here, there's a guideline of how you should be able to interpret these questions, but I can't just give you these notes and expect you to understand everything, right? Now, we must understand that f in terms of x is just the f, the y values, or g in terms of x is just the y values, or h in terms of x, or p in terms of x. What do I mean by that? I mean that when you see things like this, or maybe things like this, or maybe these just means the y values. So you should be able to interpret from there on. But this is just not even, I don't want to say tip of the iceberg, because it's not even anything. So now, what you must understand is that we are going to be using both algebraic ways to solve this and both ways to, just visual ways to look at this. Now, what you must understand is that the algebraic, okay, that is not algebra. Algebraic, how did they write this? Algebraic solving. Now, my man, these questions can be solved, but not all of them can be solved using algebra. Most of them are solved using graphs. Or what do I mean by graphs? I mean that you must be able to interpret the given graph. That's the trick in all of this. The trick shouldn't catch you out. It's just that sometimes not all of them can be solved using algebra, and not all of them can be solved using your visual, but not all of them can be solved using algebra, guys. So let's be mindful of that. But most cases you can solve using both ways. Now let's understand one thing here. Given a graph, right, of f of x is equal to x squared minus 4x minus 5. This is the quadratic, right? This is the quadratic. We can see the quadratic over here. This is the smiley face because the a value over there is positive, right? Now here we also have one g of x is equal to x minus 1. So we just see that right there. Now, -1 will just mean that this is the x-intercept of that line, the y-intercept rather, which is -1 and 0 and -1, and then the 1 right here will just mean the gradient is 1. We know how to interpret these things, and here for the quadratic it means that the -5 is the y-intercept for the f of x graph. But I'm not here to teach functions, I'm here to teach graph interpretations. Now let's start with the first question. Now they usually ask it like this. They say that use the graph to determine. Now this is the key word. They say you must use the graph. Now, in most cases, that even if you go and do it algebraically, you're going to be doing at least 4 to 7 with marks worth of work, which is really sometimes disadvantageous for people who don't understand how to interpret them using their own eyes. Now, you must be able to see this using the graph. So now 1.1 comes in and says that when is f of x greater than 0. But you must be careful of one thing over here, which is the trick also on this type of questions. They say determine the values of x, right? But they won't ask it in terms of value x. You must be able to find this, because I told you that f of x, g of x, they just mean the y values. So you have to look at the y values and answer them in terms of x. Every time we answer in terms of x, unless stated otherwise. So now I want us to go ahead and answer this one in terms of x. Now what this means is just that when is f of x greater than 0? What did we say? We said f of x is just the y values. Now you must understand the y values are positive above the x-axis. You must be able to know that. I'm going to tell you, we interpret this in terms of y values, but we answer them in terms of x values, and we're going to teach you that. Right? Now, check, it's negative below the x-axis. You must be able to understand what I'm talking about right now. Now, understand one thing. We're going to be looking where it is above, because they said, where is f of x positive? Or where is f of x, because something that is greater than 0 is positive. So where is f of x above the x-axis? That's what they mean. So you go right there, you highlight where it's above the x-axis. You go right there on your paper, you go check. This is the x-axis. Yeah? This is the x-axis. This is the x-axis. Now you check. You want your graph to be above. Anywhere above, right? Anywhere where f of x is the quadratic. Anywhere above, that graph is positive. Anywhere above, that graph will be positive. Anywhere below the x-axis, our graph will be negative. I'm just showing you how it would look, right, in terms of a sign. Now, Tina, we only interested where it's positive. But if you check, it's positive on two parts. What do I mean about two parts? Check this one right here. If you go right there and you go to this part where it starts to be above, you're going to see right there, right there from that point. And then also, this is not that point, but it's fine. Also from this point. Now, you can clearly see that the point where it starts to be positive is from its x-intercept, going to the separate directions, but we're going to answer that in terms of course, what they asked us. But now, one thing you must understand is that we don't have the x-intercept. They're not visible. We don't assume things. So I advise that you go ahead and find the x-intercept by making y equal to 0. Let's do that right now. Let's not be scared. Let's find the x-intercept of f by making y equal to 0. So for the x-intercept, what you do is that you let the y values be equal to 0, because we said these are the y values. So in this particular case, you'll have x squared minus 4x minus 5 is equal to 0. Now if you go ahead and factorize this, whether you use a quadratic or not, it's still fine. I'll go and find my factors like this. Now I'll take each bracket equated to 0, or take the other bracket and also equate it to 0. And then what do? I solve for x. X is equal to -1. But you must always know that the y coordinates for x-intercept will always be 0. So the coordinates here will be 5 and 0. And here it will be -1 and 0. You must always know that. So now you go ahead and answer them in terms of that, because the graph starts to be above the x-axis when it intercepts the x-axis. And what do we call when it intersects the x-axis? The x-axis, we call it the x-intercept, where the y values are equal to 0. So you must understand one thing, right? Here, it's not accurate. This graph is not accurate. So that's why I'm using calculations, because it's not accurate. It's not drawn up to scale, right? It's not drawn up to scale. Now, understand one thing, because here you think it's intersecting at 1 comma something, but the calculations are saying it's intersecting at 1. So let's just take the calculations. It's fine. This is not a question that will come up in an exam. It's just for interpretations. It's just for examples. They use it for examples. Now, the coordinates here for our first x-intercept would be 5 and 0, because if you go from the origin all the way to the right, the x values are becoming positive. That's why we give this side the positive x value. And then if you go from the origin all the way to the left, the x values are becoming negative. That's why we bring we say that this one is the -1 and 0 point. Now, what you must know is that if you see, what did we say? They said, where is f of x greater than 0? What did we look at? The y values. What did we look at? The y values, where they are positive, right? But how do we answer? We answer in terms of x. When are the x values positive? Not the x values, the y values. The y values are positive from the x-intercepts going up, from the x-intercepts, just not up. The x-intercepts going left, x-intercept going right. So you must be able to understand that. But now, as you go from this point of 5 all the way to the right, what are the x values becoming? They're becoming greater. So you have to be able to say that x must be any value greater than the x-intercept. Because any value greater than the x-intercept, your graph will be above the x-axis. Or someone, if you like to say it, using the intervals here, you'd say x is an element going from 5 all the way to positive infinity. You don't include the 5 because they did not include it, right? They use signs that you are given. Now check one thing. This is not only this part. That's why it's 2 marks. I mean, this is 1 mark. Now the other part will be understanding with it will also be above the x-axis, going to the left. But how do you say that? Because if you go from this point all the way to the left, the x values are becoming smaller. So you have to be saying that it's positive. Who's positive? The y values, but you answer in terms of x values. So we see that when x is lesser than or -1, which is what we found as our x-intercept, right? When x is lesser than 1. Now, if you like to say it again, but you start with a smaller number, you'd say, I'm coming from negative infinity, because as I go all the way to the left, I'm going to the negative part, right? all the way ngiyakubani negative 1. Don't include anything. You never include infinities, and you don't include when they did not include. In this particular case, they did not include, so also do not include. Right? Now, if they asked, for example, when, for example, if they ask maybe, where is f of x lesser than 0? Now you check this. What does this mean? It means you look at where the y values are negative, because anything less than 0 is negative. So we go and look at where the y values are negative. The y values are only negative from the x-axis going down. And you have to be able to understand what I'm talking about. So it's over there between that brackets, that scoop. Let's just draw it. I want to show you what I'm talking about. I don't want to just say it in here. This scoop, it'll be positive, not positive rather, it'll be negative over here. The y values. I'm y values, but we answer in terms of x values. So you come here and you draw your scoop. You see, oh, it's negative from here. But if you check there, it's not separated. Everything happens within this interval. So you can use interval notation, meaning that starting from this x-intercept, because you always start with the smaller one to the bigger one. Now, from this, tell them, from this x-intercept to that x-intercept, the scoop or the parabola is below, meaning the y values are what? Are negative, but you're going to answer in terms of x value. So you have to tell them, man, if I go from negative 1 all the way to 5, my graph is below the x-axis, meaning it's negative because the y values are negative. But if you want to, if you like it like this, you would be able to say then, man, this thing goes from, the smaller one is always on the left, and the signs must always look at the same direction. So you must never ever have something like this ever in your lifetime. You shouldn't have something like this. You must be able, it's an example because there's no number in between 5 and 5, but it's fine. For those who know, you know what I was trying to say. So don't ever have signs facing in opposite direction. They must face in one direction. If they're all looking to the right, they must all look to the right. If they're looking to the left, they must all look to the left. So now, anything in between. So what are we saying? We're saying the bigger one from the bigger one, and then the smaller one. The smaller one is always on the left. The bigger one is always on the right. And the signs, the intervals must always look at the same direction. Now, we don't include that right there. Why? Because they also did not include. We follow what they are telling us. So that is how you answer that one right there in that particular manner. And I'm just going to remove all of this. Okay, let me not remove everything because I need that equation. Maybe for those who want to be, let's solve it algebraically. So just show you would see. Besides, if maybe you are someone who struggles with seeing this, but I really urge people to understand both methods. Both methods. You must be able to understand both methods. Now, just to do it, just for the camera and just for show. They said a question. What did the question say? Let's just do it right there. The question said, yes, I need the space. Now the question said, when is f of x greater than 0? So what is f of x? You just substitute. F of x is just x squared minus 4x minus 5. You must be able to know your inequalities here. Now you must understand with here, you're just going to find your critical values. You find your critical values only if you equate this thing to 0. But we are going to come back to that inequality soon when we conclude for the answers. 0. Now then, to solve for this, you say critical values. Why? Because these are critical values because you changed an inequality to equal sign. Now, what you're going to do is do the same thing of factorizing. The same thing of factorizing is equal to 0. Understand that your critical values are 5 or x is equal to negative 1. But now, one thing you must understand is that they said, when is this f of x above the x-axis? So you have to draw your own line, man. You have to draw your own sketch. That's the problem about this one, solving algebraically, right? You must be able to understand your basics right there. Now, again, I'm going to be doing another sketch, right? You do this every time, even on algebra. I think it's question 1.4, 1.5, 1.3. They usually ask about inequalities. You must be able to draw the sketch like this. Understand, this is 0. Meaning the negative 1 would be found on the left side. And then the 5 maybe would be found somewhere. Here it's not drawn up to scale. There's no mark for this. But it's for you to understand. Now your parabola that you're going to draw here must be positive or smiley face. Because we know that if you check your standard parabola, it's ax squared plus bx plus c. You understand that when a is greater than 0, smiley face. When a is lesser than 0, sad face. In this particular case, our a, or the number in front of the x squared, is positive 1, so we must have a smiley face. So you draw, connect, don't care about the y-intercept. Don't care about the y-intercept. No one cares about the y-intercept. Right there. Now check, this is your graph. Now you must be able to understand what is going to happen. The same thing that we did, now it happens over here. You won't get a mark. It's 2 marks. You see, you just did all of this to end up at the same place, because now you have to be able to understand, okay, this is where I'm at, and this is where I should understand, all values of y below the x-axis are going to be negative, and all the y values above the x-axis should be there on positive. So you have to be able to say, okay, here's my scoop. I'm going to scoop it over here, highlight it over here, and highlight it over here. That arrow shows it will still continue. That's why we use our infinity in this particular case. Then you show my y values are positive anytime from -1 all the way to negative infinity. So you need to be able to say it's lesser than -1. Or as I said, you can also say that I come from negative infinity, because we start with the smaller one to the bigger one intervals, right? We always start with the smaller one to the bigger one. So now the smaller one here is negative infinity. Of course, it's the smallest, right? Yeah, no. Let's not go there. I was trying to speak some things that too scientifically not related to what we are speaking about here. But yeah, it's fine. Then you should be able to say that all from time 5 to positive infinity. I need to remember, what were we looking at? The y values, but we answer in terms of x values, because we know with the y values are positive above the x-axis, but we answer in terms of the x values. From this x value to the side, the y values are going to be positive. I'm sure people understand me. Yeah. So greater than 5, right? So it's the same thing. It will still land you in the same place, and that's why I said, if it's not solvable algebraically, chances are you're not going to be able to solve it using, interpretation, because most of you lack that skill. So you have to be able to say from 5 all the way to positive infinity right there. Now here we come back, and then we do this one. I want us to do the next one. The next one says that 1.2, where is g of x lesser than 0? Now anything less than 0 is going to be negative, right? Anything less than 0 is going to be negative, right? Now when are the y values of g? And I spoke to you about this, h of x. It's just the y values. It's just the y values. It's just the y values. And to show you, this is the representation of y, g, in terms of variables x. Because this is the y value in terms of x's. That's what we mean, basically. But you don't need to understand that if you're not really deeply invested in mathematics like that. But it's fine. Now, you have to be able to understand, when will the y values be negative? Now, the y values will be negative below the x-axis. We're doing the same thing below the x-axis. So you have to be able to understand that below the x-axis. Now below the x-axis, we continue with our lives. Now you go ahead and check. Let's remove all of that. Yeah, let's remove all of that. Because it's not clean anymore. Right, I need that. Okay, sharp. Below the x-axis. Now below the x-axis, you go ahead and highlight below the x-axis. Okay, it starts here being below the x-axis. It goes all the way below the x-axis. It goes all the way below the x-axis, and right from there to that particular point. Now understand one thing. You must check that over here my graph is negative. But I can't answer challenging. You answer no, I'm looking at the wrong graph. Sorry. I'm looking at the wrong graph. We're supposed to be looking at G. Sure, people are wondering what's happening. We're supposed to be looking at the straight line. So the straight line is below the x-axis, or from this point over here all the way to there, to the infinity part. Because there must be arrows to show you that the graphs continue from there on. Now G is negative 9. Y values they become negative below the x-axis. Always the y values become negative below the x-axis, positive above, right? So now below the x-axis, But how and when does it become negative? Right, it starts here from 1. But where 1 is x-intercept, and you can go ahead and prove that it's the x-intercept by making y equal to 0. So by making g of x, which is the y, equal to 0, is going to be 0 x minus 1. You're just going to solve for x. It's going to be x 1. That is the point, and the point would be 1, and you know the y value for the x-intercept is always 0. So now you must know, or 1 going all the way to the left. In terms of x values, what did we look for? We looked at the y values and what they are below the x-axis, because that's what the question asked. They said, when is g of x, or the y values of g, lesser than 0, meaning where are they negative? You know y values are always negative below the x-axis, so you go ahead and look at the x-axis. But when you answer in terms of x, where does it start to be negative? From this x value all the way to the left. You see, I stop all the way to the left is just going to be negative. Now, to answer this one, you have to be able to say when x is lesser than 1. Because on anything lesser than 1, it's this one. It goes all the way, right? But if you don't like that one, you can always say where x goes from negative infinity all the way to 1. Now, you don't include them because no one included anything right there. Now, if they ask you the opposite of this one, be a check. You were going to be able to answer this algebraically. You were able to say that, okay, g of x lesser than 0. Then what is g of x? G of x is minus 1, 0. Now here you don't need critical values because this is not a quadratic. So you just take this thing to the other side. So it's just becoming x lesser than 1. So you see, the same thing that I answered here would have been answered algebraically. So you don't need to stress about that one. So if they asked where is g of x positive, you see it's positive. Where are the y values of g positive? Above the x-axis. It starts being above right there. Above right there. When does it start being above? In terms of x values, it starts being above from 1 right there. So you must be able to see from 1 all the way to the right, my y values are positive. You can see that x is greater than 1. Every y value greater than 1, my graph is going to be positive in terms of y values. Or you can say, or in an example, please write 1. I'm just doing it for preferences. Maybe someone prefers this, someone prefers this. Now here, you go from 1 all the way to 1 positive infinity, because as you go there, we are becoming more and more positive, but sometimes you never know where it reaches. So that's why we say till infinity, because you might think it ends when I go 10. That's why there's arrows to show you that this thing can continue till eternity. This thing can continue till eternity. That's the love. That's why I love maths, because it really challenges you to think about some things. Yeah, I don't know why I'm talking about that, but yeah, you could have solved also this one algebraically. So that way it beats me up. This one algebraically, because you need to know that x minus 1 is now greater than 0. To solve for x is this one. So you see the same answer that we got here is the same answer that we got right there when we before we erased that. So yes, you must be able to show it like I'm doing it. So this should be now getting easier as we go through this. Now here they're going to say to you 1.3. 1.3 then says where is g of x minus f of x is equal to 0. Now the best way to do this would be algebraically. It's fine. It's fine. To do it algebraically, it's fine. But guess what? It's 2 marks. It's 2 marks. It is 2 marks. It is 2 marks. It is 2 marks. Just doing this would mean solving for, it would be a lot of stress. But let's do it interpretation. Now, the first thing that you should be able to understand, I don't need zeros here. I can take this brother to the other side, meaning now it's going to be g of x is equal to f of x. And guess what? The question is now easy, because now it's just asking you where are the x values, where the y values of these two graphs are equal. What does that mean? This means where do they intersect? Because at intersection points, the coordinates, both x and y, are equal. And in this particular case, the graphs intersect at A and also intersect at B. So they intersect 2 times. But where y is equal to -2. No, they asked it in terms of x. So we answer in terms of x. We know here the y values are both -2, but where x is equal to -1. Why are we not using our greater? Because bakhulume equal sign, we follow their rules. I hope you get me. And then they also intersect there at 5. At the point of intersection, their coordinates are also equal, meaning both x and y are equal, meaning yes, where the y values are equal, the x values will be 5 and -1. So, or you must be able to say or where x is equal to 5, because it happens at 2 particular points. You must be able to understand what just happened over there. But if you are the person who likes to be very difficult and try to understand too much, let's go ahead and go on this journey. What is g of x? G of x is x minus 1. What is f of x? Now, if you're minusing anything, minusing 2 or more terms, please use brackets to protect it, because signs are going to change. So now what is f of x? F of x is x squared, and if you didn't use brackets, you're going to have a problem, right? Because some signs are not going to change. Now here, the minus must go everywhere. So the minus must distribute in. So it must multiply here, and multiply here. Foil, right? So you must be able to do that. So negative times this is going to be negative x squared plus 4x. The sign changes, right? Minus, not minus, plus 5. Now, there's like terms over there, the x's. So you can have negative x squared plus 5x, because it's x plus 4x. Then this one here is going to give us -4 is equal to 1 or 0. Now here, I don't want my a to have a negative. I'm just going to divide all out by -1, -1, -1, -1. Right? What I do on the left hand side, I do on the right hand side. So I didn't do anything. Right? So what's going to happen here? This is going to become x squared. This is going to be -5x. This is going to be plus 4x. You must be able to understand that. Now over here, anything with a numerator of 0 is just 0. To factorize this, you can go and do that. I'm not going to teach factorization, but to do that, you're just going to say x minus 4, x minus 1 is equal to 1 or 0. Now, to solve for this, you're just going to say x is equal to 4 or x is equal to 1. I kid you not. These things are the same things. Same things. Why am I saying that they are the same things? Because trust me, this question, and I took this question by not by mistake, but because it was the most interesting question in terms of these interpretations. It's in terms of these interpretations. So that's why I needed it. But one thing that is they forget to say is that not drawn to scale. So by interpretation in an exam, right, if you deal with that method, because in an exam to be a at the intersecting points. But in this particular case, they did not tell you, but you can see, but you should be, it's the same method, just that it will give you different values. You saw when we did the x-axis, you see here, the x-intercept, we got 5 and 1, but look at where -1 is. But it doesn't go there. So the graph is not really drawn up to scale, which is a disadvantage, but it's not a train smash, because you still do the same thing, man. But in a more accurate question paper, of course, they're not going to make such mistakes. They will draw the graph. Maybe not really up to scale, but they won't give you things like this where when you do use different methods, you find different answers. They won't do that. So relax right there. We are still trying to understand this one. Then here, they say, that was, Tina, we answered 1.4. So 1.3 says, so let's just say 1.3, that one was 1.4. So 1.3 says g of x minus f of x is greater than 0. It's the same thing. Check what you're going to say. Take this one to the other side. So you're going to say, you can choose any to take to the other side. Now this one is going to be positive f of x. Now understand one thing. This is just asking you, where are the y values? And I'm going to teach you this very clean. Where are the y values of ubani of g greater than the y values of ubani or f? This, in simple terms and simple English, is just saying, where is g of x above f of x? This is just what they're trying to say. Now, above, we read graphs always from left all the way to right. Always, we start from this side to that side. So let's go ahead and look at where g is above x. And it happens at the same time. And it must happen at the same time. But there's no graphs anyway. No, because you don't want to have something like this, for example. Right? Here, maybe this one side. Right? And then here, this graph ends here. and then this one continues till infinity. Then they tell you that this one ends here and here. There's no arrows that continue. Then you say, oh, yo, it's above there, but no, it must happen here at the same time because it's above who? Here, it's not above anyway. So there must be a comparison. That's why we are comparing. That's why it's called interpretation, right? So now understand, we have to be able to find where g of x is above f of x. What is g? G is 1. So check over here. If you see over here, from left to right, the parabola is above. The parabola is above, right there. Check. I want us to check. Here. The parabola is above. The straight line is below at the same time. I mean, here. So this one, it won't work. And then here, check one thing. The straight line, UG, is above. But look at low, ugupi. Below. Up until gupi, that particular point. Because after that point, if you check, after that point, parabola comes back above again. And so check now, the parabola will be above, the straight line will be below. So when does G become above f of x? We just saw from this point to that point. It means all this line, all this green part over here, this is the one that I'm highlighting, all that area, all that particular area, that is when this thing occurs. Now you have to be able to answer in terms of x, but I don't want to use calculations. So you can use calculations. I don't want to use them. So what you can say, of course, you're going to get different answers. Why? Because this one is not drawn up to scale. But to use interpretation, we assume that A not be their intersection points. So I'm just going to say in between, right? Because they are not separated. So I can write them in one format. I can say x when x is lesser than 5, but also greater than or negative 1. In between, meaning in between these 2 points. Or if you like, you can say x when x goes from, right? They did not include, so don't include now. Where x goes from the smaller one all the way to the bigger one. You must be able to understand that one right there. Now we must go to the next question. Let's go to the I don't want to say like choice. What's this thing? But I don't want to make it look simple. But let's come here. Let's not say that. Right? 1.5, your favorite, guys. F of x. Multiply. We know that multiply is just a dot, right? Multiply by g of x is greater than 0. Here's where your algebra is going to help you understand this one. Understand what's about t. But when do we multiply their y values and get something greater than 0? What is greater than 0? It means the product of the graphs. The product of the graphs is going to be positive, right? Is something positive. This is exactly what the statement is saying. The product is multiplication. So it's saying, when do we multiply the two and get a positive answer? The two what? The two y values. Now, understand over here. It means for you to get something positive, you must multiply something positive with something positive. Your answer will be positive. It means for you to get something positive, you have to multiply two things that are negative. It will give you something positive. Let's come back to work. Now understand, you must be able to see what they're saying, guys. I don't want to lie. You must be able to see what they're saying. They say, multiply positive and positive, you get a positive. Multiply negative and a negative, you still get a positive. Basic science from grade 1. Okay, not grade 1. But understand this box over here. You're going to need it. Right? Now to stretch it, for you to get something negative, you have to multiply something negative with something positive. You're going to get a negative. But if you multiply something positive and something negative, the answer still will be negative. That's what they mean. What do they mean? They're speaking about if, let's say, you multiply positive 1 and positive 1, you're going to get positive 1. Or if you multiply negative 1 multiplied by negative 1, the negatives cancel out, you get a positive 1. So if you multiply negative 1 multiplied by a positive 1, you're going to get a negative 1. Multiply a positive 1 multiplied by a negative 1, you're going to get a negative 1. So if the signs are different, you get a negative answer. But if the signs are the same, you get a positive answer. That is exactly what they are trying to tell you over here. So you must be able to understand this part, this part, this part, this part. Yeah, let's not dirty the notes. Now let's go ahead and answer them. Again, someone might say, can I use algebra? Yeah, boo. But guess what? If you do use algebra here, you're going to end up with a very, very, very difficult way to understand. But a lot of ways, it's not really that difficult, but I will try to explain it in very simple terms. Now, let's go ahead. What are we trying to achieve? We're trying to achieve a positive product. When can we achieve a positive product? Product actually when we multiply two things. When can we achieve is when if both of them are positive or if both of them are negative. So let's go ahead and look. Let's just alternate them. Where f of x multiplied by g of x must give us a positive answer. Right? So we're going to look at these over here. So let's start on this one. Here. Right? Here. Where both of them are positive. Let's go check. When are the y values positive? We know that the y values are positive always. Please say with me, above the x-axis. Please say it. Above the x-axis, they are positive. So go ahead and highlight everywhere where they are above. So they start here being above. And again here being above. And then again here being above. If us understand the one part. If us understand one part. One part. This must happen simultaneously, so at the same time. So at this particular point, check what? The parabola is above. But where is the straight line? From here, from where the parabola is above. Where's the straight line? The straight line is below. So the y values of the straight line are negative and the y values of the parabola are positive. If you multiply something negative and something positive, what are we getting? A negative. It's not going to work. It's not going to work. What are we still looking at? Where both of them are positive. Now we go all the way here. It's positive up until whenever, you know. Right? And then, again, you check the other one. Where is it? It's positive all the way, because it continues. But check one thing. It must happen simultaneously. If I look and try to interpret this, from here and here, they are not above at the same time. Yeah, the straight line is above. But whilst the straight line is above, look at where the parabola is. The parabola is still tracking below. So it's like you're multiplying something negative with something positive. It does not happen. It does not happen. But now if you check over here, if you check from where the parabola starts to be positive, from where the parabola starts to be positive, right? Meaning from here. Right, all the way up. All the way up. Let's just remove that not drawn to scale so that I can be able to use that space. Yeah, right. If you check, this thing is going to continue. Continue. It's going to continue. Now you're going to understand. Over here, from here, all the way, the y values are positive. It means if you check, it must happen simultaneously. Meaning from this point here. Now, both of them are above. From which point? From the x-intercept going all the way to the right, both of them will be above. It's like we are multiplying something positive and something positive. Because both of the y values will be positive, we are going to get a positive answer. When does that happen? When we go all the way, because we answer in terms of x. When the x values are greater than the x-intercept here, we said it's 5. We know it's not 5, maybe it's 4,5 by just looking at it. But if we use the calculations that we got on the first glance, it's fine. Don't worry. If you use what's this thing? Algebra, you must still be able to find similar answers, but I'll just show you how to do it. Now, understand? Check here. Check here. Check here. It's going to be positive. Both of them are positive if you start all from here going to the right. So where does it start? We say that one is 5. So you can say that or from x going from x an element going from 5 all the way to positive infinity. They did not include anything, so we also do not include. Plus, we don't include above infinite. That's the first chapter. Now, that's the first restriction that you can use to get a positive answer. Now you go ahead and fish again. Now you go ahead and fish. Check. Now you get the second restriction. At the second restriction, we say we are looking at where both of them have y values that are negative. Because if both of their y values are negative at the same time, they're going to give us a positive answer. Let's go ahead and look for that. Now, how do we go from there on? Let's check where f of x is going to be negative. So I'm going to go ahead and check where f of x is negative and just going to answer right there. Now, f of x, which is the parabola, is negative all the way from the x-intercept all the way to the x-intercept. It's negative right there. The y values are below. The y values are below. Now, I'm going to check again. Where are the x values negative? For not the x values, the y values for one, g. Their y values are negative all the way from here to here. Now, you must understand, they must be negative at the same time. Now, when are they negative at the same time? You go ahead and do the method that I told you. You go and identify that area where both of them are negative. So you see, from here, both of them are negative. All the way, but check. From this point, say Kalenzani. Oh, I hate this. It's drawing a circle. Right? From this particular point, from the x-intercept, I want you to check. Here, both of them are below. But if I go from this x-intercept, the y values now become positive. So it's like what multiplying something positive and negative, you're going to get a negative answer. So we want them to be negative simultaneously. So we're going to check. Now, this is where they are negative, both of them. Both of them are negative. Both of them are negative. Both of them are negative. Yeah, this one is still going to be negative. This one, don't get me wrong, it's still going to be continuing being negative. But whilst it's negative, after this particular point, the other graph becomes positive, then the restriction is not met. This is what we follow every time. Now, so you check. This is something in between. It means you can represent it in interval format, in just one single interval format. So it goes from the x-intercept to the x-intercept. Now we said the x-intercept here is 1 and 0, and then we said this one is negative 1 and 0. I know it's not accurate, but use your calculations, it's fine as long as you understand what we are doing. So you can say that this thing happens also when the x, right, is lesser than 1, but greater than negative 1. Look at my signs, they're all looking in the same direction, and the smaller one is on the left and the bigger one is on the right. Every time. Now you must check both restrictions. You check all the restrictions. If it might happen, they can't be positive at the same time. Check the other restriction. You get here. You know why? If you check the mark allocation over there, it's 3 marks. And it's 3 marks. Why is it 3 marks? Ngoba lona is how many marks? It's 2 marks. That one is 2 marks. And then this one will just be 1 mark. Now, to represent this also, you could have said, x is an element going from the smaller one again to the bigger one again, right? From negative 1 to 1. X is an element of element. It's fine. It's fine. Let's just remove all of that. Now, here, someone might say, I tried to do it using algebra and I got a cubic. You are the problem. You are the problem. Guess what? Someone might say x squared is minus 4x minus 5. Then I said x minus 1 greater than 0. You're the problem, Mtana. Why? Because you want to multiply in. It's already factorized. Just factorize the quadratic. So to factorize this side is going to be x minus 5, x plus 1. Then this one becomes x minus 1. You have to equate them to 0. Why? Because I want to find the critical values. Now you take each side or each bracket and equate it to 0. If you do that, you're going to find x as 5, or x as negative 1, or x as 1. Now to do this, you have to draw your parabola. And like I always said, it's boring. It's not a parabola, a cubic. a cubic. Which, yeah, guys, I can teach this. For someone who's done calculus, you understand what I'm saying. So it's something like this. It will happen. So how many times does it intersect? Okay. Oh yeah, I check. Okay. So it's 5. So it intersects how many times here? So yeah, it intersects 1 time here, then 1 time here, and 1 time here. This is how it does. Because this is a cubic. If you multiply in the x, you're going to get x squared. This is a cubic, that is a positive. So here you're going to get that -1. Here you're going to get that 1. Here you're going to get that 5. So it's going to be very, very difficult. It's easy for me and maybe for other people. Why am I not teaching you this method? Why would you want to use this method when you can use this method? Because right now, it's up to you to go ahead and find and you will work. Because you have to find when the cubic is greater than 0. So you have to check. It's greater than 0. Where is the cubic greater than 0? The y values are greater than 0 above the x-axis. So all the way here, above the x-axis, or above the x-axis over here. So it happens right there. Now, but this one, it happens in between. It does not separate. It happens in between. So you can just say, man, x lesser than 1 but greater than -1. This is a positive function. It's a positive value. And from 5 all the way to the right, meaning x greater than 5, you get positive answers. You still get the same answer. But for those who just love maths, yeah, that was for you guys. But yeah. But I just prefer we use graph interpretation, guys, because it's just 3 marks. Please, does not undergo in this where you have to draw cubics, man. You draw cubics and not understand a single thing. Because someone might be saying, what just happened? Right? So let's not let's prevent all of that. So now the next one, your favorite also, but it's just the opposite of what we're doing. So now it's 1.6. Now it's going to be okay. Because I should be raising this. So Mamela, so we're going to be saying 1.6. What is 1.6 saying? It's saying where is f of x multiply by g of x lesser than 0. Now, it's a product. This, because we are multiplying. Understand one thing. They say that the product of these two, of the y values of these two, must give you a negative answer. Because anything lesser than 0, because if you check, from 0 going to the left, it's negative. Anything from 0 going to the right is positive. That's how we get it, right? So anything less than 0 is negative. How do we get a negative answer? By products, by multiplying. You know that we must multiply a negative and a positive. We're going to get a negative answer. Or we multiply a positive and a negative. We're going to get a negative answer. But what are we talking about? We are talking about the two graphs. Which graphs? Where is, we can just mix them up, because multiplication you found, even if you say like 1 times 2, 2 times 1, you still get the same answer, right? Then multiply by g of x must give us a negative answer. This is when it can happen. When f is negative and g is positive, or when f is positive and g is negative. But the signs must be different. But now let's go ahead and look from the graph and just deduce what I just said. Understand? We're going to check where, we're just going to be doing the same thing that we just did. Where is f of x negative? Below the x-axis, so we're going to be highlighting at that particular point. F of x is negative right there. And as you remember, this must happen simultaneously. So simultaneously, still the same thing. Where is g of x positive? Now, g of x, not positive rather. Okay, yes, positive. So all the way from above to this, to whenever. Now, this must happen simultaneously. But I can see with my 100 eyes. It starts here. Right? But check. If I arrive at this particular point, now it happens with both of them are going to be negative, so I have to stop. Are going to be positive, so they're going to give me a positive answer. So because my answer must be, check, my answer must be negative. So the signs must be different. So waga f is positive right here, and this one is negative. So that's why if it happens simultaneously, so like this, then that's when I can say it's correct. Because it's correct, because this one is positive, this one is negative, you're going to get a negative answer. But what can we say in terms of x values? The x value here is the x-intercept of this one and the x-intercept of this one. We know it's an issue. If you use calculations, you're going to get different answers, but they must be similar. It must mean the same thing. It's matter at the end of the day, right? Now, what you do with 2 and 1, I must be able to do with 4 and 2. So it's just that. Yes, it's ratios, point. Yeah. I see, guys. It matters. I see, simple. Yeah. Right? I love yapping. Now, check. it's in between. I say like if it's in between, you can just use the one interval notation because it goes from being lesser than 5 to being greater than not negative, but we always start with the smaller one, so it's just 1. So this is how you understand that one. And you know this one is 2 marks, so you can't finish right here. So it means there's another restriction. Now, someone who likes to say, you can say that where x goes from ubani from 01 all the way to 05. Don't include, no one included. And if they did include, so la, you'd have to be able to include nawe. So, and use square brackets or inclusion brackets. But you never include ubani or infinite. So let's be careful of that one. So yes, but I hope everyone understands what I just said. But the inclusivity, please, you just use the signs that you are given. Let's use the signs that you are given. Now, again, let's look at this part. Where UF manja is positive, but G is negative. Let's go ahead and look at that one. Now we're going to check which restriction. Where F is positive. No, where F is positive and which G is negative. So let's go ahead and do that. Now, to do that, we're going to check where is f of x positive, meaning above. It's all here. And then also above from here all the way to infinity. Now check again. Now where is g of x negative? Where g of x is negative, right here up until here. Now you must understand this must happen simultaneously. Now if I do this right here, check, both of them are negative. Both of them are below, so it don't work. But check if I do it from Gupi, from here, from here. Now check what is going to happen. The y values for f abanjani positive. The y values for g are still negative. It is happening at the same time, right? Why doesn't it happen here? Because f is still below, so both of them are below. They're going to give you a positive answer, and we're looking for a negative answer. So now to say that, you have to be able to say from the x-intercept. They will share the x-intercept at the same time. They will share the same intercept at the same time. If they intersect, so if they intersect right here, right, the x coordinates will be the same over here. So I can use the same x coordinates going all the way here because it's the same for both of them. Where they start, that to respect the restriction. Now to understand, to just say this, you're just going to say when x is lesser than -1, because I know it's not looking at -1, but we know it's in good x-intercept or -1 because we used calculations to prove it. Yes, this one is not drawn up to scale, but please understand what I'm talking about. Now, or you can be able to say x going all the way from -infinity all the way to -1. Don't include infinity and don't include when they did not include. That's how you solve these ones. Now, the next ones are just simple stuff again, right? Simple stuff again. Now, check. Yeah, it's going to require us to find the turning point, but it's fine. Now, check again. What you must be able to say here, 1.7. These are the most common now, so they usually come up. 1.7. 1.7, what do they say? 1.7 says that when is the first derivative of f greater than 0? What does this mean? Guys, the first derivative means the gradient, right? The gradient of a curve, right? Now, if we know that if you go up the incline, right, the gradient is becoming positive. Then if you go down slope, the gradient is becoming negative. The gradient is becoming negative. So now we're going to be understanding that. So just asking us, where, for which x values is the gradient? Y. This is not y. It has a small dot here. It's just saying when is the gradient of f positive. Now you know something like this is positive. It means, Tina, if something gradient is positive, we are looking at up the incline. Where do we start? From the lowest point to the highest point. And the lowest point or lowest point or highest point is fine. In this particular point, the lowest point on the graph will be the x coordinates on the y coordinates of the x-intercept. Now, please, this kid, not the x-intercept, rather the turning point. The turning point, right, would be the lowest point that we can go from. Now, check, to use the turning point, you can find x is equal to minus b over 2a. Now, what is your b? Your b is minus 4, so it's minus 4, 2, a 1, so you get your x value as positive 2. right? I'm not looking at the x, the y coordinate is fine. I'm not looking at the y coordinate is fine. I'm not looking at, because I'm not going to answer in terms of it, right? I'm not going to answer in terms of it, right? I'm going to answer in terms of x. That's how I find the turning point. But now, if you wanted to find the turning point again, you could have said the average. Okay, let's not do that because I was wait. They use it in IEP a lot. IEP learners will know where they add the two x-intercepts and divide them by 2. You'll get the x value for the turning point, but it's still fine, right? Yeah. Let me not trick you, guys. What do I mean? I'm saying that if the x value of the turning point, you can just say x1 plus x2 all the way by 2. Then what are you getting? The x2 will be 5. It's fine. You can choose any. And then this one will be minus 1. Then here you divide it by 2. Then guess what? Here you get 4 over 2. X value is turning. So it's the same thing, guys. The same thing. It's the same thing. But they use this one a lot in IEP. A lot. IEP and AS Maths and AL Maths. They use it a lot. Yo, I don't know why they have so many tricks. I love it. I love tricks. Right? Now, Tina Sipege up the incline, because our gradient, they said where is our gradient? Positive. So we know it's going to be positive. Look at where we're looking at. For the up the incline, we always read from left to right. So we're going to go all the way from here to here. Where are we going? Down the slope. Then we reach the lowest point. We change direction. What are we doing? Going up the slope or up the incline. That's what we are looking for, Tina. So where does it go from the up the incline? From this x value all the way to the right. So it's just going to say when the x value is greater than 2. That's how you say it, right? Because all the values greater than 2, look at what we're doing. We're going up the incline. We're going up the incline, up the incline. As you go all the way to the left, you're still going more up the incline. We're still doing the same thing. As long as you understand functions, you should be able to survive that. Now here, you could have also said when x goes from an element of 2 all the way to positive infinity, because as you go to the left, or to the right rather, you become more positive. Now, this is what we're going to be doing. Now, someone might have wanted to use the derivative and then solve for x. Now, to use the derivative, for those who have done calculus as yet, so to use the derivative, because going to 2, negative 2, minus 4. Now, we said that this thing, minus 4, must be greater than 0. So, you're going to say 2x greater than 4. Just say x greater than 2. So yeah, it's just going to be that. It's just maths, guys. Maths is very lovely. When you have those tools, you must be able to understand how to solve them every time, whether algebraically or graphically. But I always prefer with CRs in graphically, so we're able to understand what is going on. So here, if they ask us like 1.8, right? They ask us 1.8. It's confirmed, guys. It's confirmed. Where 1.8 is saying, where is f of x, the gradient of f of x, lesser than or 0? Now, if the gradient is 0, it means the gradient is negative. So if it's negative, what do we know? We know about a negative gradient is that it's going down slope, right? It's going down slope. So we're going to check on our graph lowest to highest point to check where is the down slope starting. So from left to right, what are we doing? We're going down slope up until the 2. And then as we go again, we're going up the incline. So we're not looking at that one. So we go from negative infinity to 2. That's where we're going down the incline. So here, I can just say, if I go anywhere less than 2, because every value that is lesser than 2, look at what we're doing. We're still going down the incline. From left to right, and it's down the incline. We read from left to right. This is the graph. We read from left to right. So now, everything in life, left to right. And then, now check. It's all the way from 2 to the any x value lesser than 2. But usually I would prefer this one to just say going from negative infinity, because it's coming from the negative side of the x-axis, right? So it's from negative infinity to 2. But don't include. They did not say anything about inclusion. Plus, we never include infinity ever. Right? Now the other one is this last one. Now here, I love this one. They said here it's 1.9. Interesting, but we're going to still doing the same thing again and again and again and again. Now for this one, it's going to be, where is the derivative of x multiplied by the derivative of g be greater than 0? They're just looking at what we talked about. When can we get a product being positive? Because if it's greater than 0, you must be able to understand what the answer there is positive. Then understand what we can only get a positive if we multiply a positive and a positive. we get a positive. A negative and a negative, we still get a positive. So you must be able to understand this right here. But here we're speaking about gradients, not the y values. So we have to look at where the gradients of f of x is positive, or where the gradient of g of x is positive. Then look at the other side, opposite to it again. We're still going to get a positive answer. So let's check the first one, where f of x is positive and g of x is positive in terms of the gradient. Now, when is the gradient positive? The gradient is positive when we go up the incline. So as we speak as up positive, we're looking at up the incline, right? You might be able to look at up the incline. So check, when is f of x going up the incline? Check, f of x is going up the incline from here, from this 2. We know that is 2. I removed it by mistake. All the way to infinity, right? It's going to go all the way to infinity. Positive infinity, because you're going to the positive side of the x-axis, right? That's what you must be able to do. Oh, it's kind of, but yeah, I'm enjoying this. So let's keep doing it. Right? sorry. Now, all the way from G, from 1 to G, where is g of x? The gradient of g of x positive. It's also positive right through. Why? Because gradient is constant. It's a straight line. So the gradient is 1. And it's a positive 1. So the gradient will always be positive. But I need this to happen simultaneously. Yes, it's positive right here. But yes, it's positive. Still positive here. But check it, this one. This one is negative. So when you multiply a negative and a positive, you get a negative answer. We are not looking for a negative answer. We're looking for a positive answer. So we bosh that one. So now, to continue with this one, I'll just come here and then tell them, this happens simultaneously if I start here, because gradient usually is e positive, right? But it must happen simultaneously. So from la all the way to infinity, this one is going to be increasing in terms of gradient, and the other one is also going to be increasing in terms of gradient. The gradients are also going to be increasing at the same time. Increasing or positive, it's the same thing. Right? Right. But now check. All the way from this point, from 2, we know the x value here. I need from 2 all the way to the right, you're going to positive infinity. So you're going to say where x is greater than 2, or you're going to say where x goes from 2 all the way to positive infinity. But you never include, because they did not say anything about inclusion. But if they did include over there, you have to also include right there. But in this particular case, they did not include. Or you would also have to include the 2 by using square brackets. But yeah, they did not ask us to do that, so let's not do it voluntarily. So sharp. Now that's how you answer that one. That's how you answer that one. And you check, when are the gradients? Now, this is the trick. Check. They said, where is f of x multiplied by g of x going to give us a positive answer? I say there is never going to be a situation like that, because gradient g will always be positive, meaning if you multiply it by negative, it's going to give us a negative answer. So by default, it can't happen. This scenario can't happen. So the mark there is just 2 marks, meaning it was 1 mark for that one, and realizing that there is no mark for the other one. Now, to test whether you understood what we just did, I want you to be doing the last one for me, that says f of x multiplied, the derivative of f of x multiplied by the derivative of g of x is, what is it saying? Not the derivative. It says, when is the derivative of f of x multiplied by the y values of g of x greater than 0. Please do this one for me and send it to me so I can be able to see what you did right there. I'll see you on the next one.